You wake up and can't recognize your room. That's definitely it, but your desk is on the wall, and the dresser is on the ceiling. It's closed, but you can somehow see every folded t-shirt in it. You wipe your eyes. Nothing changes. This isn't a dream. Welcome to the fourth-dimensional world. Wait, rewind. To understand the fourth-dimensional world, we need to look at the others. So, a zero-dimension world is just a point. Now, if you expand it, you get a one-dimensional world that's a simple line. It only has one measure, and that's length. The creatures living in this world can only move in one direction, either left or right. In general, a dimension is a direction in which an object can move. So now we'll add another line perpendicular to the one we have. We get a flat surface with a length and width, like a piece of paper. The flat creatures that live in a 2D world can move left and right, and now forward and backward. To turn this flat paper world into one we're more familiar with, we draw parallel lines from each corner of the square. Now we get height, the third dimension. The objects of this world have three measures: length, width, and height. They can move in three dimensions: left and right, back and forth, up and down. That's the world we live in. But now we need to figure out where to put the next perpendicular line to get a fourth dimension. It's no easy task, because this fourth dimension, as well as the fifth and 12th ones scientific theories say could exist, are hidden from us because of the limitations of our perception. While we were going through the first three dimensions, we could see that with every next dimension, we expand the possibilities. The objects become more complicated. As inhabitants of a 3D space, we can easily imagine what 1D and 2D worlds are like because they're part of our own. But for residents of those worlds, it's not that easy to understand ours because they're just not able to perceive it. Why? Imagine you're one of these 2D flatlanders and you're living your simple flat life. If a sphere, a 3D object, somehow appears in your world, the only thing you'll be able to see is a dot that appears out of nowhere, and then grows into a longer and longer line, and then shrinks back down into a dot before disappearing. A flatlander could combine all these lines to get a circle, or if he could look at it from above, he can't, that would involve height, it would just be a dot growing into a larger and larger circle and then getting smaller. Either way, our flatlander ends up looking at a flat circle, not a sphere. That's exactly what will happen to us if we try to understand a 4D object. We'll see it like a 3D object, appearing, somehow changing, and then disappearing. We wouldn't be able to make sense out of it. For example, let's take a 4D hypersphere and put it in our world. Here's what you'll see. Looks like a regular old sphere appearing, growing, shrinking, and disappearing. Good luck trying to combine the spheres all together to make sense out of its 4D shape. Okay, let's try it with something a little easier. Remember, 1D is a line, 2D is then a square, and 3D adds more perpendicular lines to get a cube. To get a 4D cube, called a tesseract, we connect two cubes. We know that every side of a 3D cube is a square. In a tesseract, every side of it is a cube. This shape looks really confusing, especially if we realize that it's a 3D projection of a 4D object on your 2D screen. Just like the Flatlanders, we're unable to fully understand what a higher dimensional world is like. Even scientists have a vague and limited perception about it. They mostly describe it in complex mathematical equations, not physical objects. But think about it this way. Technically, every single day, 4D or even 10D beings could enter our world, and we wouldn't even know it. Now, if the first, second, and third dimensions are length, left and right, breadth, back and forth, and height, up and down, what does that make the fourth dimension? How about a real-world example? There are 2D ultrasounds that show a flat black and white image, mostly made up of outlines. Then there's 3D. It's basically like a normal photograph you'd see in an album. Things have a form, depth, shadows. Then there's 4D ultrasound. This is an image that's constantly being updated with time. The fourth dimension. Some call it strength, but it's basically space-time, in and out and always. So you wake up in your room in a 4D world. The planet is a hypersphere. Everything around you is as if you lived in a sphere. Your wardrobe is still up on the ceiling, and you need to get dressed. Wait, where are you going? Stay right there. I know you still think the shortest way from A to B is a straight line, but you're in a 4D world now. The shortest way here is through. So just look through your wardrobe, find your favorite t-shirt and jeans, and grab them. That's better. Hey, your roommate is making coffee. Let's grab something to eat too. You could just teleport there, but let's take the long way. No, not the stairs, through the walls and floor. Doors and stairs will probably be non-existent in a 4D world. There's your roommate. Don't be confused, he's okay. Albert Einstein called the 4D universe a space-time world. Here, the past, present, and future all come together. So, like every other object, your friend exists in every moment of his entire life. I know what you're wondering. If you can move through walls, can you move through people too? Yeah, but please don't reach into his head and tickle his brain. That's taboo in this world. Even if it can be done, it shouldn't. Here's another cool thing. You can see people's emotions. See the yellowish shadow around him? It means he isn't in a very good mood. But wait, mentally, you don't need words here. They're too slow. You can reach any person mentally within a moment, even if they're on the other side of the planet. Now, let's grab your sandwich, laptop, some work papers. Oh no, you don't need this bag. Forget it. You have pockets, right? Put it all there. You'll see it fits perfectly. There's endless space. Well, and no reason to take things with you when you can instantly teleport. Forgot your wallet? 1 second. Now you have it. Okay, you're a little late already. Work starts at 9 and your boss is going to be seething. But don't worry. Remember, you exist in any time, present, past, and future. Even though it's 9:12 already, just get there by 9. In fact, let's take a vacation day. Teleport to Rome. See all the sights as they were through all of time and history. Master the Italian language. Where to next? When to next? The choice is yours. You can always travel back and get to your job like a punctual hard worker. And still, life in a 4D world would probably be something entirely different than even my wild imagination can come up with. So, I'll let you finish this story down below.
Imagine a basketball spinning on someone's finger. A point near the middle of the ball takes longer to spin back to where it started than the spot where your finger is. Earth spins in much the same way. People in the center of Africa are turning at 1,000 miles per hour as the planet rotates, while anyone at the South Pole doesn't really move at all, other than rotating in place. At the same time, we're all moving forward through space equally fast, since the planet is also hurtling around the sun at 67,000 miles per hour. The temperature at the boundary of our planet's inner and outer core is 10,800 degrees Fahrenheit. That's as hot as the surface of the sun. And the pressure there is 3.3 million times the atmospheric pressure at sea level. 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it's no larger than an average car, it's still a big deal. Out of more than 1 million asteroids astronomers know about, it's only the second one to orbit our planet. Called 2020 CD3, it's our temporary mini-moon. It won't be with Earth for long though. The asteroid is following a random orbit and is slowly drifting away. Temporarily captured objects, such as 2020 CD3, are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. The movement of galaxies and clusters billions of light years away from us suggests there's some enormously massive body outside the visible universe. After billions of years, the expansion of the universe will make the space so sparse that we won't be able to see the stars in the sky at all. The moon isn't a perfect sphere. It's shaped like an egg. Plus, the satellite's center of mass is a bit more than a mile off its geometric center. Even though Venus is the hottest planet in our solar system, it still has snow. But not what you'd expect. It snows metals and rains acid. Not a great vacation spot. Saturn is mostly composed of hydrogen and helium, with some traces of methane, ammonia, and water. but it contains more sulfur than Jupiter, which gives the planet a smog-like orange hue. On Earth, sound waves make air molecules vibrate, which is why we're able to hear sound. Other planets and moons allow sound to travel through mediums like their atmospheres and oceans too. In space, though, it's said that there is no sound, since there aren't any molecules to vibrate and deliver sound waves. However, not all researchers agree on this, given that space isn't just a desolate vacuum. In between the emptiness, there are clouds of gas and other stray particles. So, depending on where you are, sound waves can be possible. Astronomers know for sure that the universe is growing bigger, and the speed at which it's ballooning is increasing all the time. But if the whole thing is swelling into something bigger, then it must have some kind of an edge, right? It's unlikely that people will ever find out, but if so, then what would it be? A ginormous brick wall and then nothing? An abyss that leads to nowhere? The most common theory is that the universe is shaped in such a way that it can't have an edge, but it's not the only idea. Another theory is even more difficult to comprehend. The universe is, indeed, infinite, and our part of it isn't that unique. It means that somewhere out there, there's another you, or rather, other you. One of them is just a bit shorter, another wears their hair in a different way, and the third one is identical to you in all possible ways. There's also a theory about a multi-universe that consists of many smaller universes, and the universe we live in is just a tiny bubble among other similar bubbles. Those scientists who support this idea are also sure that bubble universes can come into contact with one another. Then gravity starts to flow between them, and when 2 or 3 universes connect, a big bang occurs, just like the one that created our home universe. Neptune is the windiest place in the solar system. Clouds of frozen methane are whipped across the planet at a speed of 1,200 miles per hour. Neptune's core is solid and consists mostly of iron and some other metals. Its mass is 1.2 times bigger than that of Earth. The temperature inside reaches 9,000 degrees Fahrenheit. Astronomers also believe that at a depth of 4,500 miles, there might be a diamond layer where it's raining diamond crystals. On Earth, people are used to a beautiful sunset that's painted in hues of orange, red, and yellow. On Mars, however, the normally pinkish red sky turns blue as the sun goes down under the horizon. It's because Mars is much farther away from the sun than Earth, making the sunlight less intense. The fine dust in the Martian atmosphere absorbs the blue light and gets rid of the warmer colors that you typically see on Earth. Whether it's blue or yellow, both sunsets look spectacular. At around a quarter of the size of Earth, the Moon is pretty enormous relative to other satellites out in space. There's nothing quite like this situation anywhere else in the solar system. Pluto has a moon that's almost half as big as itself, but it's more like a twin than a satellite. There are more than 150 moons in our solar system, and Earth's is the 5th largest out of the whole lot. There might be a labyrinth of lava tubes on the moon. Not long ago, astronomers received the results of an underground lunar topography. They discovered a massive cave under the satellite's surface. About 30 miles long and 60 miles wide, the cave's likely to be the result of 3-billion-year-old volcanic activity. After streams of lava hardened, they created a thick, hard crust on the outside. But inside, lava kept flowing, melting the rock and forming tunnels and caves. Countless pits in the moon's surface discovered by NASA might be the openings to lava tubes. We can't dig up most of Earth's gold. 99% of it ended up in the center of the planet several billion years ago, attracted by the iron in Earth's core. We're talking about 1.6 quadrillion tons of gold here. That's enough to coat the entire planet's surface in 1.5 feet of the stuff. And if all those meteorites hadn't later smashed into the ground, bringing extra amounts of gold, it would be even rarer. Not so long ago, astronomers discovered a massive blob of some mysterious substance. It was hidden underneath the surface of the moon's far side. Its mass was the same as that of a pile of metal 5 times larger than the big island of Hawaii. The enigmatic something lies almost 200 miles beneath an enormous crater that appeared on the lunar surface billions of years ago. The blob likely has something to do with a super collision. It might be the metal core of the object that hit the moon back then. Scientists can't wait to lay their hands on the discovery. It could explain lots of things about the South Pole Aitken crater, the largest known in the solar system. If it was on Earth, its oval-shaped basin would stretch from Washington, D.C. to Texas. In 2011, astronomers discovered an enormous water reservoir simply floating in space around a supermassive black hole called a quasar. Floating water vapors have been found throughout the universe, but they aren't that common. This particular reservoir holds around 140 trillion times the amount of water in the Earth's oceans. It's one of the oldest, largest, and, at more than 12 billion light-years away, one of the farthest things known to humankind. Astronauts in space can lose about 1% of their muscle mass each month. To prevent this, they have to stick to an exercise regimen that lasts 2 hours every single day. The Milky Way galaxy and the Andromeda galaxy are going to meet in 3.75 billion years. They're moving toward each other at a breakneck speed. When the two galaxies collide, they'll form a huge elliptical galaxy. I won't be around then. Have you ever looked up at the night sky and tried to count all the stars? Yeah, good luck. Our galaxy, the Milky Way, has about 100 billion stars, but other estimates put it at over 200 billion, since calculating the exact amount is an almost impossible task, even for astronomers. As for the entire universe, there are at least 1 billion trillion stars. That's one with 21 zeros after it. For comparison, that means there are more stars in space than there are grains of sand on all of the Earth's beaches. When astronomers started a project that was organized to create a detailed 3D map of our galaxy, they didn't expect to find anything surprising. But that's exactly what happened. Earlier in that year, Harvard scientist Dr. Anna Bonacca noticed a weird disturbance in our galaxy's stellar streams. A stellar stream is a line of stars that are moving together through galaxies. The stellar stream we're talking about is called GD1, and it's stretched in an impressive line across our sky. This stream used to be a cohesive line, stretched by the gravity of our galaxy. One day, Dr. Bonacca noticed a gap in it, and this gap had a strange, ragged edge. In fact, it looked like something terrifyingly huge recently plunged through the stellar stream. The sheer force of this object's gravity was so great that it managed to drag stars in its wake. The most shocking thing was that the telescopes simply failed to find the source of the damage. But then, what could this unseen bullet be? One theory suggests that the intruder is a stray star. But, according to Dr. Bonacca, the hole is way bigger than any existing star. It'd have to be 1 million times more massive than our sun. Okay, so what if the hole in the Milky Way was torn by a supermassive black hole, like the one that dwells in the center of our galaxy? If these two black holes got too close, they wouldn't be able to escape each other's gravity. A collision might be inevitable. Then the stronger of the two holes would consume the weaker one, and one huge, super mighty black hole would appear. But people have yet to witness a collision of black holes. Plus, scientists can't predict the consequences of such a merge, even though they've simulated it on powerful computers. The only obvious fact is that it would produce incredible amounts of energy. Huge ripples would travel through the entire universe, bound to hit our planet eventually. Then again, two black holes in one galaxy might refuse to merge. Imagine this. A supermassive black hole hundreds of millions of times the mass of the Sun is spinning in the center of the Milky Way at a phenomenal speed. Another spinning black hole approaches ours. What do you think will happen? Right, one of the holes, most likely the intruder, will get kicked out and sent hurtling away like a frisbee flying through space. And who can guarantee that it wouldn't head toward the Earth? Luckily for us, there aren't any supermassive black holes in the vicinity, so this theory fails to explain the mysterious bullet hole phenomenon. Dr. Bonacca still doesn't rule out the possibility that the intruder is some kind of luminous, star-like object. After tearing a hole in the Milky Way, it could be hiding somewhere in the galaxy. But again, it seems highly unlikely because of the object's huge size. I mean, we're talking 30 to 65 light years across. In any case, it's hard to predict where it would have ended up if it were a luminous object. The intruder could have been moving at an incredibly high speed and wouldn't have to be very massive to tear a hole in the stellar stream. Or it could have been moving more slowly but be very heavy. But the astronomers don't know which option it was. That's why it's next to impossible to predict where it ended up.